In today's class, we'll learn about the characteristics and process of polymer dissolution in polymer solutions. In this lesson, our learning goals are as follows. First, understand the dissolution process of polymers. Second, grasp the main characteristics of polymer solutions. Broadly speaking, a polymer solution is a stable and homogeneous system formed by mixing two or more substances in molecular or ionic states. Such a system is referred to as a solution. A solution consists of a solute and a solvent. The substance being dissolved is called the solute. The substance that dissolves the solute is called the solvent. So, what is a polymer solution? A polymer solution is a homogeneous mixture in which polymer molecules are dispersed at the molecular level in the solvent. It is a thermodynamically stable binary or multi-component system. For example, unvulcanized natural rubber can dissolve in gasoline, benzene, or toluene. High-density polyethylene can dissolve in tetrahydronaphthylene. Polyvinyl alcohol can dissolve in water or ethanol. The dissolution of polymers proceeds through two stages. Swelling first, then dissolution. As shown in the figure above, the volume of the polymer first expands, which is called the swelling process. Small molecules, however, disperse directly, which represents the dissolution process of small molecules. Small molecular aggregates eventually disperse uniformly as individual molecules or ions in the solvent. In the case of polymers, after swelling, the polymer aggregate expands in volume, but its molecules are not yet dispersed in the solvent. After swelling, individual polymer chains gradually disperse into the solvent. This constitutes the dissolution process of polymers. This figure also illustrates the dissolution processes of small molecules and polymers. From the diagram, we can clearly distinguish the difference. Polymer dissolution occurs through swelling first and dissolution later. This diagram provides a detailed representation of the polymer dissolution process. First comes swelling, followed by dissolution. At the initial stage of mixing, solvent molecules diffuse unidirectionally into the polymer chains, causing the polymer to expand in volume. This is the swelling stage. The swelling stage occurs mainly because polymer molecules are large, with strong intermolecular forces and slow molecular motion. Meanwhile, solvent molecules move faster, leading to one-way diffusion, which manifests as swelling. In the second stage, several solvent molecules enter between polymer chains, increasing the intermolecular distances and weakening their interactions. The polymer chains then gain mobility, leading to bidirectional diffusion. Eventually, the macromolecular chains become uniformly dispersed among the solvent molecules. Characteristics of polymer solutions. First, the dissolution rate is slow. When small molecules dissolve, the process takes only a very short time. For example, in a sodium chloride solution, a simple stir with a glass rod causes it to dissolve instantly. However, the dissolution of polymers may take several hours at the fastest, and several days or even weeks at the slowest. Because polymers are large in size, contain numerous functional groups, and exhibit strong intermolecular forces, their diffusion into the solvent is very slow. Crystalline polymers, in particular, must be heated above their melting points before they can dissolve. Second, the dissolution of polymers occurs in two stages. Swelling first, then dissolution. At the beginning of mixing, solvent molecules diffuse unidirectionally into polymer chains, causing the polymer to expand. At the later stage, bidirectional diffusion occurs, and the polymer chains become uniformly dispersed in the solvent, forming a homogeneous system. Third, polymer solutions have high viscosity. Strong intermolecular forces result in large internal friction. Fourth, the dissolution process is influenced by the polymer's structure. The polymer structure refers to the structure of individual polymer molecules, including chain structure and aggregated structure. The chain structure refers to the internal arrangement of a single polymer molecule, including the elemental composition of repeating units, their sequence, molecular conformation, degree of branching or cross-linking, and terminal groups. These are called the short-range or chemical structure of the polymer. The overall configuration of the polymer chain is referred to as the long-range structure, which includes both the molecular mass and conformation of the chain. The aggregate structure refers to the arrangement and packing of molecular chains, which is also known as the supramolecular structure. This structure reflects the intermolecular interactions between polymer chains. It represents a third structural level, beyond the short-range and long-range structures, and is referred to as the tertiary structure. The aggregate states of polymers include crystalline, amorphous, oriented, and liquid crystalline forms. Fifth, small molecule solutions are generally liquid, whereas polymer solutions may be solid and possess a certain degree of mechanical strength. For instance, a 5% solution of natural rubber in benzene loses fluidity and is called a gel, or PVC plasticized with 30% dioctyl phthalate. Lesson summary. First, the dissolution process of polymer solutions occurs in two stages: swelling first, then dissolution. Second, characteristics of polymer solutions. First, slow dissolution rate. Second, two-stage dissolution process. Third, high viscosity. Fourth, the dissolution process is greatly influenced by the polymer structure. Thank you.